And if you don't know what those are, you will in the next 45 minutes or so. Just got to real quickly tell you what we're going to talk about, and that's just, what is TDD? We'll actually do a very simple example of it. And then we're going to talk about the transformation priority premise, something you may not have heard of even if you've done some TDD. Then we'll talk about BDD, which is behavior-driven development. We'll do an example of that on the same thing we did the TDD from and see how easy that is to do. Just to kind of start off, how many people in here would say that you're a developer? So good. Now, how many people are in QA? I'm sorry. Let me apologize on behalf of every developer in this room to the QA people. Because we've all done terrible things. How many of you write unit tests? How many of you write your unit tests before you write your code?
I know I should.
How many of you write unit tests according to the 3 laws of TDD? Okay, so by the end of this, I hope I will convince some of you, at least, to maybe follow the 3 laws. And we'll see some of the things, amazing things you can do with that. It's going to make me have to do this now. I'm not doing that, please. I love a good demo. There. Slack popped up on my window, that's why. So who am I? I'm a senior director at Oracle. I run the custom applications consulting business. We write the apps that make up for the pieces that the Oracle product suite does not have to run the consulting organization. So customers never see my stuff. I deal with an internal customer at Oracle, which happens to be $8.5 billion in projects in flight at any one time, a user community of 25,000 users, and a product suite of about 15 different products that I'm responsible for. People ask me, well, how big is your customer? It's about the size of Kalispell, is what Oracle Consulting is. I'm also a serial entrepreneur. I've taken 3 startups to an exit via acquisition. I've worked in one startup where we actually IPO'd, and that bought my first house. But I'm still working, so I haven't had a really big exit like some entrepreneurs have. People ask me, why do you work at Oracle? And the answer is because I took venture capital. So I'm also a programmer. I have spent most of my time, in front of a keyboard, writing code. Been doing that for about 35 years now. And some of you may know me. I'm a hockey player. I play in the local league for old people. Why do we write so many tests? Why do we write tests in the first place for what we're doing? And probably the number one reason is we want our code to work. Now, I'm sure there are some people out here who might be against unit testing and are saying, unit tests do not prove that code works. You cannot disprove the existence of bugs. And I'll say, yes, that's completely true. A unit test will only prove that the particular path that you took through the code with that particular test gives you the expected result. That's all you get. So you cannot disprove it. You can't prove a negative, right? You can't say there are no bugs. But you can say that for all the paths that we have tested for, we're getting the expected results. And if we have a wide enough test suite and we're doing enough testing, then we can say that in most cases our code is going to work. And that works out a lot better than not writing the tests and just always, every day, being a surprise of when new P1s will come in over the ticket system. Why do we write tests? We like to develop faster. When people say, I don't have time to write tests, it's in the way. I say, well, that's funny, because I write tests because I want to go faster. And the reason, we'll talk about very specifically about the reasons that you go faster in a kind of a TDD type of approach. But in general, if you look at the studies, it is faster to write your test first than to not write tests at all and do your debugging downstream. We don't like regressions. How many times have you had perfectly working code and then added one little feature and break everything? Well, how do you find that you broke everything? Usually at 3 in the morning when your customers are calling to say, hey, we can't get our financials out. So with a really good test suite, you find out about those regressions before anyone else does, and then you fix them right then and there. So testing really helps because people hate regressions and fragility and that sort of thing. Does anyone here write perfect code the first time? Yeah, no. That doesn't happen. No one writes perfect code. Tests help us detect that situation very quickly and fix it before it becomes a problem. We want to be able to detect changes that broke our code. I'm not talking about just the changes I've made. I'm talking about those idiots down the hall who made a change to a library who broke my code, or the security team who put a patch in last night at midnight and now nothing works. And it's really nice to find out about that stuff before it goes out to the customer base and becomes a big issue. We'd like to be able to refactor without fear. How great would your life be if you could refactor code and say, that's going to work, I'm fine? Because we're all aware of the Pottery Barn rule, right? You break it, you bought it. If you see a piece of code, maybe you didn't write it, and it doesn't have any kind of tests associated with it, you'll look at that code and say, oh, that is a mess. I really should go in and clean that up and make it better. No, because if I break it, I'll have bought it. I'll own it. When it doesn't work, people will come to me. They will scream at me. So I'm just going to step away from the keyboard and let that messy code continue, which is a very bad thing for the product going forward. We want our code to be self-documenting. Now, I'm old enough to remember when we had COBOL, which was self-documenting, right? No, it really wasn't. Tests are a great way to document code because they show exactly what the code does, as opposed to comments, which are merely just wishful thinking on someone's part of what the code would do. But a test will actually show you what the code does. We want to be able to iterate quickly. Facebook pushes 1,400 times a day or so, I'm told. That's a pretty quick iteration cycle. You can't iterate if you've got to go through a gigantic manual process to check your code every time, right? If you've got to send something over to a QA team and it takes them 3 weeks to go all the way through, every single path in your system, there's your iteration rate, 3 weeks. But if you've got a comprehensive test suite and you are confident in that, you can iterate with pushing a button. You can let that code out into the wild. We don't want to spend a lot of time debugging. How many people are really good at with your debugger? You write a lot of bugs, don't you?
I deal with a lot of other people's bugs too.
Yeah. When you're using TDD, you kind of lose that debugging capability because you're just not spending as much time in debugging. You're spending more time on the development side, and that's where you want to be. I used to be really good with debuggers, and as I became more of a TDD adherent, I kind of lost that mojo. I'm not so good at debuggers anymore. I think that's something good. We want to find our bugs early. There's a theory that says the later in the process that you find a bug, the higher the embarrassment. I think that's probably true, right? So let's talk about what TDD really is. Because a lot of people, you'll say, hey, do you use TDD? Oh yeah, I write unit tests after I've written all the code. Well, do you write 100% coverage? Well, no, not really. Some things are not testable. Why is that? So TDD says you're not allowed to write any production code unless it is to make a failing unit test pass. Right? So that's kind of hard to get your head around. We're used to just kind of sitting down and saying, oh, I have this problem, I'm going to just churn out a whole bunch of code, and then I'll write a few tests afterwards to see if it worked. And if it doesn't, the tests are wrong. Move on. Code works. TDD says you can only write as much of a test, as much production code, as to make a test pass. And you are only allowed to write as much of a test as is sufficient to fail. Now think about that. And compilation failures are failures. So I start off with a very simple little test, and then I write a little bit of production code, and then I write a little bit more test, and then a little bit more production code, and I'm never going for more than one thing at a time, right? I'm always just doing a little bit of production code, a little bit of test, and it's just kind of a yin and a yang, and they build each other up. So I end up with really two systems at the end. I have my complete testing system, and my complete production system, and they are tightly coupled to each other, right? They're going to work together. You're not allowed to write any more production code that is sufficient to pass that test. So that leads us into this kind of red-green refactor cycle, where first we write a test that fails, that's red. Then we go to green, which is make the test pass. Have you noticed that, like in all your little unit testing tools, whenever it goes bing, test passed, it's in green? Yeah, that's why. And then yellow is refactor. Refactor just says, look at that code, should I make it better? Because first we make it work, and then we make it better, right? And since a refactor means I'm only changing the structure but not the behavior, my test can just keep running as I refactor. Refactor a little bit, test. Refactor a little bit, test. Refactor a little bit, test. As long as that test keeps green, I keep refactoring until I look at it and say, oh, that's beautiful. Now I move on to the next thing. Heard a talk earlier today about how to do or not to do big refactoring projects. You don't want to fail at a giant refactoring project? Don't do it. Do small refactoring projects. Do it as you code. TDD can guide the solution to very difficult problems. When I'm teaching people at Oracle how to do TDD, I like to pull off like a medium leak code. Anyone know what leak code is? Right, it's kind of what the Apple, Google, Facebook, those people use for interview questions. These are devilishly hard algorithm type problems. And what I like to do is just grab a leak code medium and work through it with TDD. And after, while working on it, people look at it and say, oh my gosh, we just solved a problem. I don't think I'd have failed that in an interview. I was like, well, yeah, that's why whiteboard interviews are terrible, because you can't TDD them. You have no compiler. But it allows you to solve problems that might be beyond your algorithmic knowledge, because TDD itself is a formalized way of attacking these algorithms, and it will lead you into a solution that you hadn't thought of when you started. You ever have writer's block with coding? You got a blank screen and you just can't think of the first thing to do. TDD solves the writer's block because you just have to write that first failing test. In that first failing test, well, just go after the degenerate cases. Test for 0, test for -1, test for a null value coming in. Just write something, get it on the page, get into the flow. TDD does that. But the other great thing about TDD is dopamine feedback. You know what dopamine is? It's that little great feeling you get when something goes right. I would bet, and I ask this question in interviews a lot, why did you get into software? Why did you decide to become a programmer? And invariably, we all got into this because at some point early on in our lives, we wrote a small program like Hello World or something like that, and it worked. It would ding, we got the right answer. Remember that feeling of how good it was when that worked? When you're doing TDD, you get that feeling like every minute. Because every time the green light hits on your test, you get that little dopamine shot, and you just get high off it, work on it all day, which is very different than you code for a whole week and then it doesn't work and you just go home for the weekend, right? So TDD gets you that feedback. Testability. For those of you who write your code first and then come back and write unit tests, how often you just throw up your hands and say, there's no way to test this? So we'll bypass that and move on because that piece is not testable. That situation is impossible if you're writing the test first. If you're following the 3 rules of TDD, you cannot write something that is not testable because you're not allowed to write it except to pass the test. You wrote the test first. Dependencies. Have you ever run into trouble with dependencies in your project? Something just won't link together because of the order in which you did things, and you put it up on the whiteboard and you notice you got lines going both ways. You can't get into that with TDD so easily. I mean, you can work your way into it, but you won't find dependency problems as much because you have to specifically mock out those things that you're going to be dependent upon and kind of set them up in your situations as you're coding. So you tend to avoid those kinds of things, and your architecture all of a sudden becomes much cleaner. So again, it forces good architecture. I've got ahead of myself there. So everybody that I talk to that doesn't like TDD just says it's slow. You're writing twice as much code. You're writing the code that actually does something, and then you're writing the tests. So you're having to write twice as much. Well, there have actually been studies on this, and they looked at it and they said, well, what is the overall life cycle of TDD versus non-TDD? And they found that using TDD, you decrease your overall time by 40 to 90%. It's like, well, why is that? Well, the normal software development project goes on in kind of a development mode for a while, and then we get to that kind of first release of, we're going to toss this over the wall into QA. And that might have been like the first 80% of the project. Once we did all the coding, and now we send it over to QA. And now we do the other 90% of the project, which is called debugging. Right? So this is added up to more than 100. We spend a lot of time in the debugging phase fixing things as we go. With TDD, your debugging phase is much smaller because you built the tests up as you went. And you end up with very, very high test coverage because of the 3 rules. They won't really let you write stuff that you haven't tested. The larger and more distributed your team, the better the effect of TDD. I want you to think about that. If I'm geographically spread, and I've got, personally at Oracle, I've got teams in Texas and California and Bangalore. Most people are in Bangalore. And they're doing pushes into the main line, every day or so. How much time would you normally spend just dealing with those collisions? But if you're running TDD and you have a unit test that you can run the suite against everything, then you don't break it so quickly, because I'm not running just my tests, I'm running everything before I push. So that allows you to have, you don't have to have everybody in the same building when you're doing TDD. It works great for distributed projects like open source and things like that. People really push you to where your unit tests on this when you try to check something in. And it's the same thing if your team is distributed. My team measures sprints per bug. That's our metric, not bugs per sprint. Think about that. When is the most expensive time to find a bug? I would say it's in front of the customer, right? Or during the sales demo, or at 3 a.m. when the customer calls and says we can't get our financials out, or some other horrible thing. It is much better to do your bug discovery upstream. What this chart shows is that with TDD, you're finding your bugs pretty much as you build them, right? And that gets the feedback loop very, very tight and very quick, as opposed to a test after. You're not finding them until you've broken a lot of other things as well. So that's a real advantage in decreasing the time from code to bug. Cost of change. The problem with doing all of your tests afterwards is you can allow your system to become fragile, because you weren't testing all along and you weren't able to make changes quickly. Now your system is more resistant to change. Likewise, you can't refactor as easily. If you're refactoring all along, now your system becomes much cleaner and it's using good architecture. Remember, we were forced into good architecture with the TDD, but if we take a test after or a no test approach, we end up with these systems that are really difficult to make changes to. So the study showed that kind of over time, this TDD agile approach, the cost of change just kind of stays flat. So now we're actually going to do something in TDD. Anybody familiar with Fizzbuzz? So if you look at the Wikipedia page, you will see this explanation of it. This is leak code number 412. It used to be an interview question at Google, and then someone wrote an article about it. They don't ask this anymore. But the Wikipedia will describe this as a children's game for teaching multiplication or division. That is untrue. I know this for a fact. I was in college. It's a drinking game. You miss the fizz or the buzz or the Fizzbuzz, you take a drink, and then you get worse at it. So if it's a multiple of 3, we say fizz. If it's a multiple of 5, we say buzz. If it's a multiple of both, we say Fizzbuzz. You're probably thinking in your head right now, oh, I can write that code in one line. And you probably can, but you might get it wrong the first time. This example is silly and stupid. We're not doing this because it's hard. We're doing this to demonstrate TDD. So I fired up BDD, and the first test I wrote was the degenerate case, just to break my writer's block. I couldn't figure out how to do this. And I did test 0. And then I wrote a little bit of code down here at the bottom. It just said, function Fizzbuzz, going to take a number. If num is less than or equal to 0, return false. And I ran my test and it passed. Now, why not just start writing this right away? And the reason is that there's kind of a rule about TDD. Don't go for the gold right away. Work your way into it. Let TDD drive you. Don't try to jump ahead too far. So the next thing I did is I said, all right, well, I can handle 0. How about 1? So I wrote a test, and I said, let's assert that if I give it a 1, it'll give me back an array of 1. Right? And I wrote my test, and the way I wrote the test, and then I wrote the little code, and I just added, well, if it's equal, num is equal to 1, then just return an array of 1. Working code. Right? I've covered the first 2 cases. Yay me, I'm the programmer. So I said, well, what about 5? Because that's the first one that's going to say fizz. And so I wrote a test, and I said, if I give it a 5, I should get 1, 2, 3 fizz, 4 buzz. That's the answer. And then I started writing code. And I said, well, I did 0 and 1. Let's do 2, let's do 3, let's do 4, let's do 5. Hey, that works. That program is correct. And it runs really fast. I just have to cover all the cases up to infinity. Yeah, Miss Cleveland says, ooh, that's nasty. So now we're going to get to the one thing you should take away from this talk. The transformation priority premise. Everybody knows what a refactoring is, right? Refactoring is we change the structure of the code, but not the behavior. But a transformation is a simple operation that changes the behavior of the code. So we're making changes to the code. As there's a saying in TDD, as the code gets more specific, the tests get more generic. Right? So we did a whole bunch of very specific tests. Now we would like to make the code more generic, because obviously. So there are a series of transformations that this guy, Uncle Bob, Robert C. Martin, familiar with that guy? He's a big proponent of TDD. He came up with this set of transformations. And it just says when you're transforming code, you're basically kind of moving down the page here. That is, from blank to no, from no code at all to a nil, that's a transformation. From a nil to a constant. From a constant to another constant. Just kind of read through each of those, and you can Google transformation priority premise. It'll have all of these for you on a cheat sheet. But the one that we're kind of, there's a couple here that we're interested in, because like the first thing we did was statement and statement, right? And then we did conditionals, and we just did a whole bunch of conditionals. So it's kind of like we want to, somewhere in here, make a change to that code that instead of being line by line by line, maybe we should employ a loop, something like that. So now we've changed the code, and we said we can go from if to while. That's a transformation. And the if to while gives us this kind of ugly looking code, but it looks a little bit better. And it just says, okay, for the first case, if num's equal to, because we wrote, the same test, First case, if num is equal to 0, return false, but then we're going to have an array or a list called res, and for I in range of 1 to num plus 1, if modulo of I3 is 0 and is 5 is 0, then append Fizzbuzz. Otherwise, if it's 3, append Fizzbuzz, and it's a 5, append Fizzbuzz, and otherwise just append I. And then return res at the end. And then I run my test, and yes, my refactor worked. So I followed the transformation premise, and to do that, ran it, test still passed. Now I can refactor this. That's nice, but it's still not quite there, I don't think. Right? So another transformation we can do is expression to function. That is, we can look in our code and see expressions, and we can pull those expressions out into a function. So in this case, we made a function called Fizzer, and it does relatively the same thing. And now our Fizzbuzz function has been straightened out dramatically, and it just says, return a list where Fizzer sub I, where Fizzer is in range, Fizz is in range, right? Pretty simple. That will give us the same answer. And I run our test, and yes, it gives us the right answer. So now we're just going to start adding more test cases to it, right? I'm going to skip ahead and say test for 15. It worked for 3 and it worked for 5. Now I should probably check all the way up to 15. So there's that, and I run the same thing. Bing! I got a little green light. A little shot of dopamine. Yes, it did work. It's still not looking quite right. The add more test cases, you should also, here's where you start adding little corner cases, right? Cover the stuff that you didn't do in the degenerate case, but now you're thinking of, and just all the things that could go wrong. Like, for example, what if num was not an integer? And this is Python, I could get this anything, right? So I might put a case in for that. First, I would write a test, assert that if I hand it the word Greg, it will return a false. Run that test, it will fail against this, and then I would add that to the code, and then it would pass. And then I would run all my tests, and everything passes. So that's how you kind of handle the corner cases that QA will come up with and make your life bad. So now we can gulp it a little bit. I can just say Fizzbuzz is Fizz where not I is %3. That is, if we're going to multiply the characters Fizz by I not being divisible by 3, right? Same thing with that. And it runs in one line of code, and you run it through the profiler, and it's slower. So that's a key item. Your unit test can include performance assertions, right? No reason you shouldn't test for performance all the way down here. So I'd probably go back to this and just say, you know what, I'll call this back. So a lot of people will say, we don't have time to learn this. I'm too set in my ways. I'm just not willing to do it. Yes, there is an initial performance hit to develop it. It will take you a little bit of time to get your head around it because you spent your career doing it the other way. I would submit that if we started off in Computer Science 101 and we taught people the 3 laws of TDD as just being the normal way to do your coding, when you came to them and said, you know what, you can skip right to the code and just write and not write tests at all, they'd have no idea what to do and have to be trained in how to do that. They would just look at you like you were crazy. Well, it's the same thing here. You are going to have to think about it, and all I can tell you is try it out. Just give it a shot because it really does work pretty well.
I wrote my first test senior year. Yeah, not good.
You will more than make up for this on your first project. At Oracle, we tend to hire recent graduates. The rule is recent graduates from the top computer science schools with, top half of their class, yada yada. Brilliant young people that come into us. knowing absolutely nothing about software engineering. They can write Java code, but they don't know how to be programmers. So in my group, which is different than most of Oracle has not caught on to this, but in my group, we teach them TDD before we'll let them write code. And that consists of a week-long training course, videos and exercises and all kinds of stuff to go through to learn about TDD, and we throw in a bunch of architecture too, about solid, because when you're doing TDD, you need to follow good architecture. That's because otherwise you'll write yourself into corners, and TDD will just kind of force you into, I don't know how to solve this. Well, yes, because you made an architectural mistake, and TDD is pointing that out to you. We take them through 16 hours of one session per week of the thing we call Code Mania. And we basically take a problem, we start off with kind of elite code easies, and by the end we have them working on problems that we had run into in our own systems, and you go solve in TDD. And it's just every Friday for an hour, everybody goes off and does that. We give a weekly award. Most of the guys are in India, so they're cricket players. We have a cricket bat, and every week we award the cricket bat to someone in the hopes that they will not use it on their managers. And after you've won the cricket bat, I think 5 times, you can sign the cricket bat. So you have your name on the bat. And the best person who did TDD that week, who applied it the best, a little positive reinforcement, you get to carry the cricket bat that week. You can bring it to meetings, you can do whatever you want with it. Within 6 weeks, we're getting competency out of people on TDD. I think it's 6 months. I think it's a lot faster than that. But when we go back and look 6 months later, it's like, wow, this is really clean. We had a group that went through this training and then went into a project, and the project had basically built a large monolith that needed to be ripped apart and broken down into services. The monolith had been built with TDD, so yeah, you can do some bad things with it. But we had this huge unit test suite. We had predicted about a 3-month project to tear that monolith down. 3 weeks, worked perfectly. And it's just because all the tests were there. So if you're having to do those big things, do it with the tests. Places it doesn't work so well. Well, concretions versus abstractions. Everybody know what a concretion is? Think concrete, something hard, like a GUI, a database, things like that. You can't really test a GUI with TDD very easily. You can do it. You could use, kind of a GUI test tool or something to run it. But in general, most of the work you're doing in GUI is, I want to move this over here. I want to add a field there. That pixel needs to go over there. That kind of stuff. That's not what TDD is about. TDD is for more of the back end, the business logic type stuff, the stuff that's deterministic. So if it's an abstraction, it's really easy. And the nice thing about this is this will force you to separate your logic from your GUI. And if you're embedding logic in your GUI, shame on you, the QA people hate you. Don't test things that you just have to assume work, right? I mean, don't test that .NET works. Don't test it if I create an object, the object is created, unless you wrote the object system. Don't test the database is working. Don't test the framework is working. There's no point to those tests. We're just kind of given that, well, the framework has a bunch of unit tests of its own, right? So leave that in place. Don't test things that aren't repeatable, right? They have to be deterministic. You can't test the system clock, right? Because it'll give you a different answer every moment. Don't do a project to write tests for all your legacy code. Now, when you get fired up on TDD, it's really easy to say, oh, I've got a 10 million line legacy code project. Let's go back and test everything on that and fix it. Yes. Let me know how your next job works out. Make the tests, write the test as you make changes. That has the benefit of your tests will cluster around the areas that are changing. And those are your problem areas anyway. What we do is when a bug comes in, the first test you write is to prove the existence of the bug. Right? So now you have tests that will fail because of the bug. And when that test passes, the bug is gone. We also label the test name with a pointer back over to the JIRA for, that was that bug. So we got I can look at the issue and I can see, yeah, there's the unit test for that issue. That puts you in a place where now you have unit tests so that you don't repeat your bugs, right? Nothing worse in the world than fix a bug and then 6 months later something else breaks and the same bug comes back. This stops that. So that was TDD. Let's talk about behavior-driven development. TDD is all about unit tests, right? We're testing the behavior of units of code. Behavior-driven development is kind of outside in. It's testing the behaviors of our systems or of our product. It is much more user-centric. It's saying things like, when I log in, I want this to happen. As opposed to a unit test that says, the login event should make the following changes. So a little slight difference there. BDD is about acceptance testing. It is made to be understandable by mere mortals. Users, product owners, that sort of thing. It is written in a language that they can understand. And if you're really good at this, they will write it for you. How awesome would that be? Let me know, I haven't gotten that down. It uses a given, when, then syntax. That just says that given a scenario, when an action takes place, then this is the result. And we can embed variables in that. You'll see an example of all of this. But that is a very kind of natural language. It's English-based, and you can teach this to users. You can even teach this to managers. The language is called Gherkin, and it does the automation of that plain English syntax into actual test code. There are Gherkin translators in every language you can think of. In Java, it's Cucumber. In Python, I think this is Behave. PHP is Behat. They're all some variation on that. But that's just literally a translator that runs against a feature file and produces a code syntax for that text. So here's the Gherkin for Fizzbuzz. And we first start off with our feature, which is to play the Fizzbuzz game. And the feature, just a little quick English explanation of what we want to be there. And then we have a scenario. And the scenario says we're going to play with a number. So given the game has started, when I enter a number, and you see the syntax for number there, that tells us that it's going to be a variable. Then the answer is produced. An answer is going to be a variable. And then over here I can see examples. My first example is low numbers. And I just put in my first test that I had there. I missed a test. Anyone notice the one I missed?
3.
That's 0.
Yeah, I did test for 0. You'll see that later. But I did this, I'd already taken the screenshot, and then I took a later screenshot, and I was like, why don't I have 100% code coverage? Oh, I missed a case. So I left it in here and figured I'd make it a learning moment. So I ran behave, and that created all these stubs for the test that we just ran. And then I just have to go in and write the test code that responds to those stubs. And that test code can use number, which is being passed into me, as a variable, and it can use answer, which is being passed into me, and I can just make my assertions that way. So now I have a full set of acceptance tests for the Gherkin that we wrote on that. If I run my automatic coverage checker, ooh, I didn't get full coverage. We just talked about that. But you can run, in a lot of tools, like I'm using PyCharm here, you can run the coverage checker against the feature file. And it will tell you the coverage of your tests against those features. You can get static HTML reporting out of it, that it will go through, and your screen will look a lot better than that. But go through and just tell you what your coverage is and what tests have been run and kind of where you are in the project. What is the difference between BDD and TDD? Well, the answer is do both. BDD is your acceptance tests and TDD is your unit tests. So you don't want to skip one of those. You want to do both. You start with BDD, you're working with your customer, your user, your manager, whoever it is you're doing this for, and building up that English language, and then that gets you a set of acceptance tests in code. And then you use TDD to get all those feature tests to pass. And the way I do that is I just follow the same rules of TDD as I'm going through each of those. BDD is actually useful for testing interfaces where TDD is not, because BDD describes the result like the human wants to see them. So you can hook it up to Selenium, and you can have Selenium fill in those feature tests. BDD is great at avoiding scope creep, because when you're doing your 2-week iteration with your customer and showing them where you are, and they say, hey, it should do such and such, does that require a change to our Gherkin? It does. Huh? Okay, now I can do change management on that. I mean, I'm willing to accept changes, but let's be clear that this wasn't in scope. How do you get this in? Well, this is what I'm trying to do. It seems to be working so far, but I have not gotten to the end result, which is I want my users to write the Gherkin for me. But what we do is the user hands us a requirements document. I can't get away from that. They're dinosaurs. They want to do that. So they'll hand me this document like this, and we'll turn that into a set of user stories. And we'll come back to them and we'll say, do these stories reflect your document? Did we rephrase this in a way that reflects both our understanding of that? And we'll argue about that back and forth for a long time, but we'll come up with a bunch of stories. Those stories go into Jira, and then we go through, and it's usually right now, it's our product manager, in working with the developers, writes the Gherkin descriptions to go along with all the features that those stories talk about. And we did a really cool little hack where we can actually put the Gherkin inside the Jira story, and got a thing that calls the Jira API and extracts all the features out of that, builds the feature file, and then runs the Gherkin for us. So we're kind of going right from Jira story into test code. The developer picks up those acceptance tests, uses TDD to implement the features. Our hope is that eventually the users figure out that if they just give us Gherkin, the whole thing goes faster. They have figured out to give us stories. So that's a big step forward, but I'm probably years away from getting them to do Gherkin. But if you're a smaller, more nimble company, get your users to talk to you in Gherkin. That's what it's there for. TDD dates back to the 1960s. This is not controversial. A lot of people will say, oh, that's newfangled. No, it was rediscovered in the 1990s. In the 1980s, I was doing something similar. I worked at a company that did geographic information software, and we wrote the test and then we wrote the code to fit that. We didn't do TDD, but we did test first, back in the 1980s in C. Dan North proposed BDD in 2013. So anybody who's against all this newfangled stuff, you can point out that they're at least a decade and a half behind. Don't be a dinosaur or a cowboy. Questions?